Hello. This section is a revisit on the topic of core concepts, understand the Kubernetes API primitives. And as we remember, the API itself, there's a concept of API endpoints that are resourced, that is, that are backed by persistent resources, and then there are API endpoints that are non-resourced. And today we're going to focus on the ones that are backed, those persistent objects. And as a reminder, the command we can use to remind ourselves what objects are persisted, there's a command called kube control API resources. API resources. And that command outputs all the objects, one per line, and then it has a name, a short name, the API group it's part of, and whether it's namespaced. And one thing real quick, and there's a kind. Now, one thing that's important here, again, is API group, it's blank, that's essentially the core group. The rest of them have actual group names, right? One thing that wasn't clear was the meaning of when do you use a name, when do you use a short name, and when do you use a kind. So we'll see, and if I may have already been mixing things up a little bit, but the name or short name are valid when you're using the command line tools. That's how you refer to. So for example, if I'm referring to a config map, right, I can either use config map singular, or CM. And then when we're in files referring, there's some configuration files, and we'll see more of those coming up. When you refer to a config map, you actually use this title case, config map. So that's just something, the short names are for command line, and the kind is actually used in the config file. Another thing is looking at these objects, right? We saw this before. There's a concept of objects being namespaced or not, and that's this column, which is namespaced, true or false. So for example, our config maps are namespaced, right? And the meaning of the namespace really has to do with the name. So every object has a name, and it has to be unique, but the uniqueness is either cluster-wide or namespace scoped if it's a namespace kind of object. And so we've already seen that. And then we saw that there's UIDs that auto-generated. So if when I create an object, it actually under the scene creates a unique identifier for the object that it maintains, and that's cluster-wide. So there's two commands I'm going to look at here just real quick. And we've been mixing these up a little bit. So if I do, let me clear the screen, kube control describe, and this is something we had created a lot before. So I'm describing the config map called example. And you can see it has a sort of nice, easy to read format where it's kind of formatted the output for sort of human consumption, right? But we've also used a command that looks more like this. I think I've done this at least once before. So if I do without any special output, by the way, I kind of get this summary output when I get an object. But the important one is getting this output in this YAML format, because that's going to feed into, well, we'll be looking at more YAML files shortly. And so I'm basically getting that object, but I'm outputting in YAML format. And you notice I basically get out the same thing as that nice describe view, but it's a little bit more structured. And I get more raw data out of it. For example, here's my UUID, and if you looked at the describe, there was no UUIDs presented. So there's more information that you can get out when you look at it this way. So that's just a side note. When you read data, describe is sometimes useful if you're trying to kind of quickly look at it, but if you're troubleshooting an object, you might really want to just dump it out as YAML and then inspect it. So that's that. Another kind of object or another metadata that we haven't talked about much is labels. And the key with labels is that, well, I think the easiest way of looking at this is look at the sample labels, and then we'll talk about it in that context. So I'm going to run a label. I'm going to basically get out the raw data for one of the nodes. Okay, pause the video for a second. I may have not restarted my nodes yet, so let me pause the video and come back. Actually, I just restarted the nodes and their IP addresses changed, so now I have a new IP address. So I'm going to basically get the YAML output of a node, and you see you get a bunch of information. Now, in particular, I'm interested in this section called labels, right? So this is under metadata, right? And of course, we see our name, right? And this is not namespace, so there's no namespace. There's our UID, but then there's all these labels. So labels, a couple things about labels. One is that they're key value pairs, right? The keys obviously need to be unique. The values are strings. The structure of a label's key, there's sort of two formats. One is what you're looking at here, which is it's got a prefix that looks like a domain name, followed by basically a string. Beta, Kubernetes, IO, Arch. Okay. Another format is just without the slash, just a string. Distinction is, so those are the two formats, either domain name slash string or just a string. And the purpose of that is to scope the labels. And depending on the purpose, you kind of know where the source of the labels come from. So a lot of these labels, for example, are all related to the hardware of the box, right? And big picture, labels are, the way we use labels within Kubernetes is to help discover objects. So if I wanted to say, for example, and we're not going to do it right now, but if I want to run a command that says, show me all of the, actually, I'm going to pause the video and I'm going to actually do it. But what we're going to do is I want to show all the nodes of type Linux, right? And that's kind of one of the features of labels is that we can use them when we're looking for resources or objects. We can sort of filter down the list of things. So that's kind of the main purpose of labels. And I'm going to pause the video and I'm going to queue up a command to show that command. So as I recall, I was just left off with the idea that labels are a mechanism that Kubernetes allows you to basically reduce the if you're looking for nodes, for example, you can do a filter saying, give me only nodes that meet some criteria. And labels are how you can filter it. So for example, of course now, there. So the command that I'm going to use here is kube control get nodes. And then I'm going to provide a label, which is one of the labels that we saw. And then I provide a key value pair. And it will then give me a list of any nodes that match that label. And you can do, now, again, I only have two nodes, so it's kind of irrelevant. But you can also do comma separated pairs, like key equals value. Okay? So that's how essentially labels are used for this kind of operation, either in the command line, but more importantly, when we start looking at some of the configurations later on, we'll be using labels in configuration objects to refer to other objects. So it'll become super important, okay? Now, one thing that they do mention in the documentation, and I haven't been doing this, but maybe as a practice, I'll be going forward when we start doing our examples and more complex examples, is that they're suggesting that when you create objects, you should use the standard set of labels. It's not required by any fashion, but it's recommended as a pattern. And using labels of this format, so again, it's app, Kubernetes IO, and then there's name, instance, version, component, part of, and managed by. And this is all around the idea that you group your resources based on a concept of a quote-unquote application. So the idea is you might, conceptually have a group of resources that all work together to deliver some particular purpose or application, and you want to somehow group them together so that you can discover them later. And the recommended patterns are use these kind of labels for these purposes. So, for example, the name is the name of the application. Instance is the particular instance of the application that this component's part of. And then the version right, and whatnot. So just an interesting pattern. Going forward, I'm going to try to use this as we develop more complex examples. Okay, so the next concept is called annotations. And we actually can see that our node itself, so grep, whatever, history, hang on, grep, node, right, so the last one was bang 2132. So this was the command here was, I just ran the command to get the node and output in YAML. So we saw the labels previously, but notice that, where is it? Okay, there's some annotations here too. So they are also key value pairs, so it's easy to confuse them with labels. But annotations cannot be used to do filtering, so this is, you can't put things that are, you don't use them for filters. What annotations actually are designed to drive some change in the behavior of this object to external systems. So in this case, I'm guessing that these values here are being used by AWS as they manage the node. And that's the importance of that is not within Kubernetes, but it's important outside of Kubernetes. So we'll see annotations later on specific to Amazon that we want to configure something external to our Kubernetes, and annotations is where you will put those kinds of things. So that's really all. They're just key value pairs, just like labels, but they're used not for filtering, and they're not used internally within Kubernetes. Okay, so now we're going to change gears. We talked about sort of the metadata. Now we're going to talk about the data itself, right? And if reading through the docs, there's one common pattern where you think of Kubernetes objects as sort of a combination of sort of the desired state, that's the spec, kind of what you, when you configure an object, this is what you want it to do. And then the status of the object is driven by the system itself, so you don't drive the status into it. Kubernetes drives the status values, and that's kind of the actual state. So I think the term they use is record of intent. So the spec is the record of intent, and the status is the actual state. And you can see that this is the pattern that exists when we look at our node object, right? When you get down to the data, there's really only two things. There's a spec, and then there's the status, right? And there's a lot of status, obviously, in here, and very little spec. Okay? Some other objects we'll look at will be reversed. There'll be quite a bit of spec and a lot less status, right? So this is an example of object that follows that pattern where the data is spec and status. Now, that doesn't mean that every object has spec and status. So when we looked at our config map, for example, get config map example out YAML, its structure is different. It has metadata, but the only thing it actually has in terms of outside of the kind is basically the data itself, right? So this is a different kind of object. It doesn't have a spec and a status. It's just data. Okay. So, but most objects that we work with later on will have a spec and a status. Okay. So now we're going to get into sort of change gears about how do we manage these objects. And at first I thought this was going to be a super simple section, and I ended up being surprised at how deep it got. And so when I first looked at it, I thought it was overblown, but it turns out that there's a fair amount of complexity here, and I'm going to attempt to explain it. So first thing is we're going to look through three different patterns for managing objects. And one big thing that you'll see all over and over again is that once you start managing a particular object using one of these techniques, you don't switch. You don't switch to another object midstream, another management technique for that object. As a matter of fact, there are ways to transition between them, but it's manual and not prone to error, but it's tricky. So you can switch techniques, but it's in the docs. You will need to be careful about how you do it, and there's a very particular pattern for switching. So let me see. So let's talk about the three different mechanisms. and we're going to look through a config map example and see that pattern, and that basically interacting with a config map and those three patterns. So one is called an imperative command, one is called an imperative object configuration, and one is called a declarative object configuration. Generally, the documentation would suggest that the easiest one to understand is imperative, all the way down to declarative being the most complicated. And I'll qualify that slightly when we go through the examples. And just the big picture is, by the end of the game, you're actually pretty much, if you're doing things the recommended way, you're only using declarative object configurations going forward, right? So, in fact, everything I've done so far, my learning has always been doing declarative object configuration, not knowing these other ones even existed. So, depends on how you look at it. The most common pattern in most of the tutorials use the bottom one. But we're going to go through all three here. So the first thing is imperative commands. So the first thing to remember about imperative commands when you're managing that object, the Kubernetes state itself, like the state of the object is sort of authoritative. I mean, you should be in your mind think the data is in the object, and I'm just using command line options to change the object state as it exists in Kubernetes. So that's the way you should be thinking about it. So to make this more concrete, let me delete. I'm going to delete that. Let me first go in here and delete that example code. So, example config map, right? So somebody do kube delete config map example. Okay, so what I'm going to do is I'm going to do kube control create. Let me copy and paste it, and then we'll look at the command. So there's a Kubernetes command called create config map, and then you provide the name of it, and then there's these command line options to kind of drive what you're trying to do. So in this case, it's from a literal value where A is apple, B is banana. And if I hit that, right, and created the config map, and then of course I can then kube control. Let me get it again. So get config map. I want to show the detail of it. So okay. So you can see it created the config map and Bama. It's got a date stamp on it. Pretty much what you expected, right? So this is an example of a command that is a command line, command driven, imperative. The data lives in and there's nothing. I didn't have a file on my machine. I just told it to build the object, right? I guess related to that is you can delete objects this way too. So, for example, if I do kube control delete config map and then example, and we've been doing this a lot, and then you delete the object. So that's an example of creating and deleting commands, objects in Kubernetes that are through a command line imperative, like you're just telling it, this is what I want you to do. Now, in terms of config maps, there's only creating and deleting with command line tools, as far as I know. There are other objects in Kubernetes where you can run command lines that actually modify that object in Kubernetes in place. So we'll look later on, there's things called like deployments, and you can just scale deployments up and down, right? And there's different commands you can learn to do that scaling. And so that's one technique of managing objects in Kubernetes. You create them, and then you use various command lines to manipulate them. So the downside for that, for me, by the way, is that now you have to memorize all these different, lots and lots of command line options and commands to do various things, which I find harder than some other techniques we'll see later. Okay, the next kind of object is called imperative object configuration, right? And in this case, I think, again, I'll just do it by example. So, and then I'll explain it. So there's a file here called example.yaml, right? So this is an example of a configuration file. a couple things to notice here, again, is that the first line, some things are required. For example, you have to provide the API version, which is a combination of the version and or the API group. Because this is the core group, there's only really a version number. If you look at some other examples of this, you'll see API group and the version. The kind of object, right? And again, config map, this is using the kind, right? Not the short name or the other name, right? This is using the kind. If you look at that, remember that column of output. The metadata, we have to supply a name, right? By default, if you don't give a namespace, it goes into the default namespace, so that's what's implied there. And then in this case, you provide a data, A apple, and B banana. So an example of a imperative, okay, and now let me just run it and then we'll describe what imperative meant here. So kube control, create, file, example. Right, so that created that, and of course we can then view it. And there it is, right? Just like we did with the command line. So the difference between this and the previous one example I gave was this was driven from a file, right? We used this example.yaml file. So it's file-based, but it's imperative in the sense that we're telling it specifically, hey, you, Kubernetes, create this example YAML. In fact, if I ran this file again, it should give me an error saying that the object already exists, because I'm trying to create an object that already exists. So that's an example where, again, we're telling it precisely what to do. And then there's another command we'll look at here, kind of related to this, is called replace. So let's go into example, right? And see cantaloupe. So if I want to update this object, I'm going to change that. And then, you know what I'm going to do here too? Let's see if I can get this to work. I'm going to look at this object real quick and then pay attention to the time. So there's a creation time. So this was done at 16:20. So it's 22 right now. So what I'm going to do now is I'm going to do kube control replace -f example. And if I do, so the creation time, it's interesting. I was expecting, it's interesting, the creation time did not get changed. It still says 16:20. I really thought that the creation time would change. I wonder if the UI was different. Actually, I'm going to check. This is a random sidebar. See the UID here? It's E68. Let me replace it again. It's interesting. Yeah, I did a replace, but it didn't actually change either the creation timestamp or the UID, which is fine. I was really expecting those to change. But the key here is that replace essentially deletes all the values, and then puts a new object in. That's what I was kind of expecting the creation timestamps to change. But what this means, though, is we're driving the configuration with the data that's in this case, we're treating like the data that's in the file as the source of truth, right? So we're just basically wiping out the object and putting a new object in place with the same name. And it looks like also the same creation timestamp in the UUID. Again, that seems strange to me. But the key here is it's imperative because we're telling it to create, and the source of truth in this case is the file itself. The value in this case, cat example, right. Now, one of the things that's a problem looking ahead, it's not so much true for these config maps, but there are other kinds of objects where the values of the spec data gets changed by some external source. This will come into play with like deployments and things like this. And where values of the object are actually changed outside of your file. And the problem with the pattern of using this imperative approach was every time you push this file, it'll wipe out the object and reset it back to this was, and you lose the managed state of some other field that you're not even managing in this file. So, and that becomes a real problem. Good example is deployment, and there's a number of replicas, and you can have some mechanism that is managing this replica value outside of your configuration file, but every time you push this, you basically reset that back to a default value, which is not what you want. So this is why this imperative approach is not the best approach, because you can only configure what's in your file. Okay, so that's the imperative approach. Let's see if there's anything more. Oh, okay. And then I guess the last kind of two things on this. We've been doing this all along, but if you want to delete this, you can do cube control delete. Instead of just deleting the object itself, you can actually just pass it the file, and it'll delete every object that's in that file, right? So we just deleted the config map. So that's an example of deleting something using this pattern. Okay, so the third process, and again, seems to be the recommended approach, and it's the one that I actually learned first, where we're treating the state that's in, and the tricky thing is a little bit more complicated. That's why maybe it's got more nuanced behavior. So first of all, we now are back to using Kubernetes state as authoritative. So the files are there. They're there more to help drive the change, but they're not the authoritative data. So, and we'll see how this works through the example of our, we'll look through this example. We'll go through our example and we'll explore this. So the first thing you'll notice here is we're going to use the same file. So again, we'll start off with this. So here's our same file. Nothing's, instead of doing a create with this, we're going to do cube control, so we're going to do cube control, apply, so we're not doing a create. Okay, so this looks, and you'll notice that it creates the file. It creates the object, right? And if I can describe, and then if I do the same command again, before with the create, it said, oh, there's an error. Now it's actually saying that's okay, because the object is unchanged. So it didn't actually do anything, okay? So this has a little different behavior. So the meaning of apply, right? And we'll go through the logic of it more carefully. Essentially, though, it says, hey, this is what I want the final state to be. That is, I want to have an object. You're basically saying, I want an object that looks like this. And so when you apply it, the first thing Kubernetes does is checks to see, hey, does that object exist? And if it does, or if it doesn't, it creates it. If the object already exists, it's going to see if anything needs to be patched, any changes to the object. It doesn't delete the whole object and recreate it. It does a diffing process to see what needs to be changed in the live object to get it to this new state that you provide in the configuration. So it has a sort of a different sort of logic to it. It's not replace logic. It's more like, hey, what needs a change logic? And we can see that in play. So for example, what I'm going to do here is I'm going to make a change to my example. So this, I'm going to add something. Actually, I'm going to add something here. D, what's a fruit with a D? I don't know if it's fruit with a D. I'm going to use dog. Okay, so I'm going to add something. And if I do now I'm going to do another command that's related to this, which is more like a gut check. It doesn't actually do the change. It just tells you what it's going to change, right? So basically, what it does is telling me, oh, the change it's actually going to do is it's going to add a dog. It's not going to recreate the whole object. It's going to make a differential patch saying, I need to add just this one entry in the object. And then we can, of course, then apply this, right? And then we can view it, if I can find it. Of course, I'd probably be faster just type in it, right? And now it's got the dog in it, right? So the logic here is different in the sense that it's using the live configuration and calculating a difference. So now it turns out, and I think the easiest way to see this, right? So here's the logic that this mechanism uses, right? The first thing it's going to do is look at, it uses a combination, I guess I should look at one more detail here. I kind of skimmed over it. So let me clear this again. Let's look at the actual object. There's an important thing to look at here. And it's this annotation that was not, so first of all, when we were doing the creating objects before using the imperative methods, we didn't have these annotations in here. And this is an important difference. See right here? It basically is called the last applied configuration. And it has basically a JSON version of what you provided in your YAML file. So this is keeping track of what you configured this through your declarative statement, right? And this is going to be important here in the logic of how it manipulates these objects going forward. So let's do this. I'm going to look through the logic real quick. So the logic extracted from the documentation, right, is the first thing it does is it uses three inputs. One is the configuration file that you're using. One is the live state of the object. And the third is this annotation field that keeps track of the last time this thing was changed through a declarative statement, right? And it uses those three objects, those three things, to calculate out what the difference will be. So the first is fields to delete, right? And what it does, it looks at your last applied configuration, and it looks at your configuration file. And if there is something that's in the last known configuration but not in the configuration file, it's going to delete that entry. So that's how deletes rely on that last known configuration to figure out what to delete. Next thing to know is what to add. And the logic there is it uses the live configuration, and it uses the configuration you have in file, and anything that does not exist in the file, in the live configuration, but exists in your configuration, your file, it'll add or update. Okay, so that's the logic. Deletes are using last known, and adds and updating are done through the live configuration. So let's go through an example of this and see if I can explain. So the current state of the object is should be, it has, in terms of last known, it has A, B, C, and D, right? And that's how last time we configured it, we provided all three of those. And the current state has A, B, C, D, right? So what I'm going to do is, if I go into example, so first I'm going to do is I'm going to delete D, add an E, okay? I don't know, the eggplant, eggplant, it's sort of a fruit, okay? So in this case, the logic should be, it should detect a deletion on D because the last known configuration had a D, but this doesn't. And then this should also detect an add because the live configuration does not have an E, eggplant, but this does. So let's see what the diff looks like. Cube control, what was it? Diff example, right? I should see a delete on dog, and then I see an add on eggplant, and that's exactly what the calculation was, and that's what happened. And then, of course, I can apply it. Control apply -F. And then if I get it, probably in history somewhere. And it should say the last known configuration had no D in it, has the E in it, and of course the data is exactly what we expect. So there's some subtle logic around how deletions are calculated as well as additions. Now, I guess kind of related to this, and I can't really create it with this example, but if there are, one important feature of this, if there are values in this object that are not in the configuration file, say like this example, deployment with the number of revisions or something like that, right? There's something that's managed outside of your configuration file, the configuration file will not touch that object, right? Because all this is going to do is only manage the values that are in that config, it's going to use this last known config and the current config to calculate deletions and adds based on that. It's not going to touch other unmanaged or unmanaged fields that are outside the scope of the configuration file. And that is really the key benefit of using this approach, is it allows you to manage an object yourself and allow other mechanisms to manage other parts of the object separately. And that's a key feature of Kubernetes. So that's pretty much why this approach of using declarative management is pretty much the only way to go. Okay, so I think that's all of this. Now there's a couple other details here. So let me, one is, how do you delete an object? How do I delete an object altogether? I can't necessarily do that. If I wipe out, for example, if I go into example and delete the entries here and then apply the empty file, it's not going to do anything because it doesn't know, like, there's nothing to do, right? The logic doesn't really do anything. So the way you delete objects, even when you're doing, give me a second. Okay, we're back. I got distracted for a second here. So the question was, how do we delete this config map now that we've created it, and how do we do it with the declarative approach? And the answer is we don't. For deletions, we always fall back to a more imperative approach. So that's the way you delete things. So in this case, I can delete the example by just config map. I've been doing just like I was doing with my imperative file approach. Delete config map example. Oh, okay, bear with me. Oh, there it is. Delete example, and it'll delete it. I could also delete it with the command line option too by just deleting the example config map too. Again, deletions are done imperatively even when you're doing a declarative approach. Okay, the last thing I believe we're going to cover, well, one of the last things is, so the question now is, another benefit of using the declarative approach is that you can go in and you can manage more than one object at a time. And because you don't have to tell it whether to create or delete, it will calculate for every object what it's going to do. So in this folder here called project, I've got example, which is the same thing that we had earlier, right? There's a config map called example with A and banana. And then there's another one though called example 2 with looks like names of cities, right? And the key here is now I can, instead of just applying it to a file, I can do kube control apply -f project, and that will now operate on any object that's in the project folder, right? And in this case, I can go into project and I can go into example, for example, and I can add just to it cantaloupe, right? And if I do a diff, so if I do kube control apply diff project, you will see that it can calculate out that one file needs to be updated and another one doesn't need any change. As a matter of fact, I can also go in there under project and create a new file called sample.yaml, example3.yaml, example3.yaml, and I just call this example3. So I'm creating a new object altogether. And so in that one, let's see what it does here. So let's clear. So now it's going to say, if it works right, it's going to say, hey, I need to make a change on one object, right? And then I need to completely make a new object here. So this is doing a combination of patching and creating of objects, right? And if I could apply this, kube control apply -f on project, it will configured one object was unchanged, and it created the third object, right? And then, so anyway, that's the main, one of the nice things about this approach too is that you can manage a whole collection of objects and it will determine whether it needs to change, create. Again, deletions can't be handled this way, so I'm pretty sure if I was to go in the project and say, well, if I want to delete example 3, right? Right, so this will not work. It better not work, but let's see. If I do a diff here, it's not going to do anything. Deleting the file doesn't actually tell it to delete it. So the only way I could have deleted it was to run that delete command. So I would have to, well, it's too late now. Let me actually do it here. So let me go back in the project. I need to reconstitute that example 3.yaml. No, example 3.yaml vi example 3, and this was called example 3. So I just kind of brought it back to its previous state. So if I go here, if I remember right, if I do my diff, should be no changes if I didn't make a mistake, right? But I can do control delete project, and it'll delete all the objects that exist in that folder. So now I don't have any config maps. Okay, so that's an example of a declarative approach for creates and updates, but then you have to use it some more of an imperative approach for deletes. And the last thing, I'll just mention it quickly, is there are some trickiness, and I don't have a great example here, although I'll show you an example in the documentation, and you can look at this on your own. But what happens, there are scenarios where you're creating objects and managing your fields, and some other writers, maybe a default value or some other process is managing another value that you need to somehow reset. Something got off, you don't want to manage the value, but somehow you want to like reset it, delete it, but you don't want to manage it. And there's an example of this in a very specific example where this can happen in the Kubernetes documentation. And you can look at the notes for the link, but this example here about, let's see, it's actually probably, let me bear with me. If you scroll down, there's a section about default values. And of course now I can't find it here. Hang on, it's probably, oh, here's default. So there's an example down in the link about default field values, and they're going to this example where you have a deployment object we haven't talked about, but your definition does not specify a strategy. So, but that strategy actually gets automatically managed by, here it is right here, right? That this is automatically applied automatically. The strategy is already set, and then there's some other thing called replicas. This is all managed outside of your config file. And then what happens is you find yourself where you want to switch something, but you need to somehow vaporize, you want to change and manage maybe one of the fields, in this case the strategy, but there's some other data that's lingering around. In this case it's this rolling update, right? Which you need to somehow wipe out. You don't want to manage it because it wasn't something you had set, but at the same time you need to somehow affect it. And they give an example here, and again I'm not going to go into detail, but you can basically set, this is the main point, if you want to reset something without managing it directly, you can set the value to null, the string null, and doing so in your config file, right, you are basically telling the server to, hey, delete it and reset it back to default value, but it's not going to be a managed value that you're going to manage. So again, that's a very specific use case, and it's something I just want to make sure I pointed out, so that if you find yourself stuck in a situation where you need to change externally written managed value, but you don't want to manage it, there's a trick around this using a null to do that. Okay, so I think that is all I really wanted to cover in this video. Right, so that's it. So long story short, of the 3 mechanisms that we want to use, I mean, we talked about metadata stuff, but more importantly, it was all about the management techniques. And the recommended strategy is using declarative object configuration, right? Where the authoritative state is stored in Kubernetes, and all you're doing is telling it what you want to change, and it does this calculation of figuring out what needs to change in the object and just applies the patches to make the changes that are necessary. Okay, that's it.